Have you ever used Zomato, BookMyShow, or Flipkart and wondered what's actually happening behind the scenes? The part you see, tap, scroll, and interact with, that's called the front end. It's the visual layer of any app. When you click a button, fill a form, or swap through images, you are using front end code. Front end is built using HTML for structure, CSS for design, JavaScript for logic and interaction. Modern apps use frameworks like React, Vue, or Flutter to make things smoother and faster. But the frontend isn't just about looks. It handles input, validations, sending API calls, showing loading states and results. Now, let's take a real world example and walk through how this works step by step. What really happens when you click place order on Zomato? From your side, it feels like just a click. But behind the scenes, a lot happens. Your action travels from your browser or app to the backend server, to the database, and sometimes even to the restaurant's kitchen screen. All in seconds. Let's go step by step and understand how this works in simple technical way. Frontend collects your data. The frontend is app or website you are using. It's usually built using React, Vue, or React Native for mobile. When you tap place order, the frontend collects your everything. Your user ID, the restaurant and food items IDs, your delivery address, your payment options like UPI or card. All this packed into a small data format called JSON. Like this. Now the frontend sends these to the backend using a post request to an API like zomatos.com/orders/place. The frontend's job is now mostly done. It waits for a response. Now the request reaches the backend server, usually built in Java or Node.js. First, it checks, is the user logged in? Is the restaurant open? Is the food still available? Can we deliver to the selected address? These checks happens inside different microservices. Microservices are small backend programs that handles different jobs. For example, order service handles creating the order. Inventory service checks if food is available. Paymentary service manages payments. Notification service sends SMS or emails. These services talk to each other either via APIs or using message queues like Kafka. If everything looks okay, we move to the payment step. If you want to know about microservices in details, please go through this link. Now, the backend calls a payment service. This may connect to UPI partners like Paytm or PhonePe. We send the payment request to their system and wait for a result. If payment succeeds, we get a success message with a transaction ID. If it fails, we stop the order and send an error back to the frontend. To make this reliable, we use features like retry in case the payment service is slow, timeouts so we don't wait forever, circuit breakers to stop calls when a service is down. If you want to know about these features in detail, please check out this link. Once payment is successful, we save your order in the database. The backend will insert a row in the order table in Postgres or MySQL like this. We use relational databases here because they support ACID, meaning the data will always be correct, even if something crashes halfway. Sometimes other databases are also used. MongoDB for flexible data, Redis for caching order status, Elasticsearch for admin dashboards and search. If you want to know about these databases in detail, please check out this link below. Once this order is saved, it gets a unique ID like ORD9083. Now the backend sends a response back to the frontend like this. The frontend uses this to show order confirmed. Page will arrive in 32 minutes. It may also start tracking the delivery using a live map. This live tracking works via WebSockets or polling, ways for the frontend to keep asking the backend for updates in real time. While all this happens, more things go behind the scenes. The order is pushed to the restaurant screen, a notification is sent to the delivery partner, data is sent to analytics or logs for the future reports. Your preferences are saved for the next time. All these use other services like Kafka, RabbitMQ, and background workers. So, in short, that one click did all this. Frontend sent your order data, Backend validated and processed it. Payment was handled securely. The order was saved to the database. UI was updated in real time. Background systems were notified. And all of this happened in under 2-3 seconds. That's the power of full stack engineering. Front end, back end, and database working together smoothly. Thanks for watching. See you in the next video where we will deep dive into the front end and back end services.